In this video, we're going to take a look at a legal problem called longest common subsequence. So we're given two strings, and we want to find the longest common subsequence out of those two. So if there is no common subsequence within those two strings, then we're going to return 0. And a subsequence is basically a string that basically is a subsequence, right? In this case, a subarray of a string. So here you can see we have an example of A, B, C, D, E. And this is a subsequence of this. So you can see there, A is from here, C is from there, and E is from there. But we have to keep the relative order of the remaining characters, right? So I cannot have A, C, B, right? This is not a subsequence of this because you can see that C is after B, right? So in this case, this is not going to work. And it doesn't have to be contiguous, right? So you can see that we can have a subsequence like this, or we can have a subsequence like this, or A, C, D, right? So it doesn't have to be right next to each other, right? The character doesn't have to be right next to each other to be a subsequence, right? So as long as it's within the string, and it must be a relative order of the remaining characters, right? So now let's take a look at the example, right? If I have a string like this, right? So the longest common subsequence is going to be 3, because you can see here I have A, B, C, D, E, and another string is A, C, E. You can see A is here, C is here, and E is here. So the longest common subsequence is 3, right? And you can see here we can also have another example where we have exactly the same, where the size of two strings are exactly the same, and the characters within the strings are also the same. So the longest common subsequence is 3, right? And you can see we can also have another example like this, where they don't equal to each other at all. So we have A, B, C, D, E, F. So they don't equal to each other. Then in this case, the longest common subsequence is 0, right? So we're only interested in the number, like how many characters are the same, right? What's the longest common subsequence, the size of the longest common subsequence, right? So how can we solve this problem? So one way we can do this is we can use a brute force approach. And the brute force approach is that we can try to get each and every single combination. So if I have ABC, like I want to get each and every single subsequence, right? And try to see if that subsequence is contained in the other string, right? But this will give us a time complexity of exponential. So this is not the most optimal solution. So how can we improve this? So in this case, we're going to solve this problem using dynamic programming. And the idea is that we have to focus on the small problem. We're going to focus on the sub-problem. So let's say we have given an example where we want to know the longest common subsequence if I have an empty string, right? So I have a function, I take those two strings, and those two strings are empty. So what's the longest common subsequence? So in this case, the base case is that if they're both empty, or if one of them is empty, then the longest common subsequence is 0. Because I can also have a function, right, that has an empty string here, but I have a character A, right? And if I have something and versus nothing, then there's nothing in common, right? So the longest common subsequence is just 0, because I have nothing inside those two are common, right? But what if I have something that's in common? In this case, if I have A here and A here, then you can see that the first character of both strings are equal to each other, right? So in this case, if those two are equal to each other, then we need to know the common subsequence for the remaining characters. So in this case, for this function, it's going to be 1 because we found something that's in common. Plus, we want to know in this case, the common or the longest common subsequence for the remaining string, for the remaining characters inside a string, which both of them are empty, right? So in this case, if both of them are empty, we already know that they must be empty. They must be 0, right? In this case, the longest common subsequence, if one of the string is empty, is 0. So in this case, the longest common subsequence, right, for the remaining characters inside the string is just going to be 0. So we have 1 plus 0 is 1. So we have one common subsequence, right? The longest common subsequence out of those two strings is just 1. So let's say we have another example where we have fn, and in this case, we are going to have a string like AB and another string which only contains A. So the longest common subsequence for those two strings, right? In this case, obviously just one, but in this case, we first check to see if the first characters of both strings are equal to each other. In this case, they do. So in this case, what we're going to do is we're going to remove that out of the string. And then we want to know the longest common subsequence for the remaining characters. In this case, we only have B for the first string and empty for the second string, right? So, and we know that if there's one of the strings are empty, then we can just return 0 because the longest common subsequence with empty string is just nothing, right? You have nothing in common. So in this case, 0. So 1 plus 0 in this case will give us 1. And longest common subsequence out of those two strings is just 1, right? But let's say we have an example where we have B and C, right? And let's say we have A and B, okay? So what's the longest common subsequence if I have B, C, and A, B? So in this case, what we have to do is that we check to see the first character. In this case, the first character doesn't equal each other, right? In this case, doesn't equal each other, then what we have to do is we have to try with other combinations, right? In this case, usually if I want to know the longest common subsequence for BC and AB, I have to try with all the combinations. In this case, if I have B here and AB, the longest common subsequence is just 1. If I have BC and AB, the longest common subsequence is just 1 as well, right? And same thing here, if I have C and AB, the longest common subsequence is just 0. And if I have let's say BC and A, the longest common subsequence 0 as well. If I have BC and AB, the longest common subsequence is 1. If I have here something like B, right, the longest common subsequence is 1. So in this case, what we had to do, you can see that we're comparing the first character many times, right? Because we already compared the first character already, so we don't have to do this. And we also don't have to do this as well, right? Because we already compare A and B as well already, right? We check to see if AB is already in this case already doesn't equal to B, right? A does not equal to B. Then what we had to do is we had to check the remaining substring, right? In this case, C was AB and B was BC, right? So in this case, what we're going to do is we're going to take the maximum, the longest common subsequence for if we have B here, right? And in this case, we have C here, right? We're not going to compare B. So C with AB, and we also need to compare it with BC with B to get the longest common subsequence, right? In this case, the longest common subsequence for this guy is 0, right? Because C has nothing in common with AB. And the longest common subsequence for this guy is going to be 1 because B is in common with B. So BC in B, right? B in BC is 1, right? So in this case, we check to see the first character. In this case, they equal each other. And we do the same thing. In this case, it's going to be 1 plus the longest common subsequence for C and empty string, right? It's empty string. So it's just going to be 0, right, for this guy. So it's just 0. 1 plus 0 is just 1, right? And for this part, is the same thing. Is either, in this case, C and A does not equal each other. So what we're going to do is we're going to say either we're going to get the longest common subsequence, right? If I have fn empty string and AB, right? Because we already compare with CB anymore, so we're not going to have those combination with C in front of it comparing with A. So we also going to compare with fn C and in this case with B, right? In this case, because the second character, we don't want to compare C with A anymore. We already compare that. So in this case, C and B does not equal each other. We have an empty string that's 0, so total is 0, right? So you get an idea, right? This is basically how we're going to solve this problem, is that we're going to break this problem down. In this case, if I have ABC and DEF, if those two, if it either it does equal each other, the first character does equal each other, or it doesn't equal each other, then what we're gonna do is we're going to break it down to subproblem. We're gonna based on the result that we're currently getting, once we compare the first character out of those two, we're gonna get the longest common substring for the remaining characters, right? So to solve this problem, basically what I have here is I have a string. In this case, I have defined those variables, right? In this case, I have t1, which is the size of text1 dot length. t2 is the size of the text2 dot length. And then I have a cache 2D array with the size of t1 plus 1 times t2 plus 1. And the reason why we have a plus 1 there is because we're going to have an empty string. There could be a point where the string, right, is empty, right? In this case, if it's empty, then we can just return, or in this case, we can just set it to 0, right? We can basically cache that using a cache 2D array. And just like a table that I draw here, let's say if we have AB comparing with AB, right? In this case, here I have A, here I have a B, right? And then here I also have an A, here I also have a B, right? And you can see here that if I want to know, because we're going from top down, right? So if I want to know the longest common subsequence from AB to AB, right? In this case, for those two strings, then the longest common subsequence, right, is going to be, because those two are equal to each other. So in this case, we're going to remove B, and we want to know the longest common subsequence if we have string A and A, right? So let's say if I have a function, right, I want to know the common subsequence. Then in this case, what's going to happen is, because A and A or B and B is equal to each other, right? So we're going to know, we want to know the answer, right, the longest common subsequence for the remaining character, right? So I have A here and plus 1 because B, they're equal to each other. So in this case, if that's the case, then it's going to be 1 plus the answer of this, right? So which is the answer of here, right? So it's going to be the previous row and the previous column, which is right here, right? So we know that those two are equal to each other, so it's 1, right? So that's what we're exactly doing here. You can see is that here we check to see if one of the strings size, you can notice that we're passing in the size, right? The size of the string. So if the size, or if I should say the current, the size, right, is empty, if that's the case, then we can just return 0, right? And then what we're going to do is we're going to see if we've been pre-compute this value before. If we pre-compute this value before, we can just return pre-computed value. And then what we're going to do is we're going to see if the last character of the two strings, right, if we have AB and AB, the last two characters are the same. If they are the same, then we're just going to say 1 plus, right? We're going to remove, in this case, this is basically the size. We're basically shrink the size 1 to the left, right? In this case, we only have A now, right? So we passed in a function, and then we passed in the size. In this case, the size is just 1, right? 1. So we pass that in, and then we're just going to continue to do the following, right? And notice that we're here, you can see here, we're doing character at, because because the t1 is the length of the string that we're going to pass down, that we want to compare the longest common subsequence. So if I want to get the last character, if I want to compare the two strings last character, I need to do t1 minus 1, t2 minus 1, right? So that's what we're trying to do here. And at the end, you can see we're returning 1 plus helper t1 minus 1 at t2 minus 2, t2 minus 1. And at the end, you can see we're going to return that answer if the last two characters are matched. If they don't match, what we're going to do is we're going to do the alternative option, right? In this case, just like I mentioned before, is either going, if I have a BC, and in this case, I also have, let's say we have AB and BC. In this case, the last two characters doesn't match. Then what we had to do is either we have comparing AB and B, or what we're going to do is we're going to say A, right, compare A with BC, right? Because we don't want to compare C and B again. We want to compare the remaining characters, right? So that's what we're exactly doing here. is that is T1 minus 1, right, is basically T1. So T1 is this one, right? T1 minus 1 is either the remaining characters if I remove the first character, if I remove the last character in T, right, in text 1, or is going to be if I remove the last character of the text 2, right, then we're going to compare B with B1, AB, right? So this will give us the result, and at the end we're going to basically get the largest value, right, out of those two paths, and we're going to cache that in our 2D cache array, and then we're going to return that at the end. But you can see here this will give us a time complexity, right, of a T1 times T2, right? And because we're using a 2D array to cache those results, so the space complexity is also going to be T1 times T2, right? We have a 2D array with size of T1 plus 1 and T2 plus 1 as well, right? So, and basically this will give us a result of big O of T1 times T2 for both space and time complexity. And now let's take a look at how we can do this using a bottom-up approach. So to do this using a bottom-up approach is a lot simpler, in my opinion, because you can go from the top of the table all the way to the bottom, right? So as long as you get this idea, like, it's pretty easy. And basically you can see here, same thing for the first slot is basically 0, because if I have an empty string and I have an empty string, then in this case it's 0, right? There's nothing in common. And let's say we have those AB back, right? So you can see here, if I have AB here, I have AB here. Basically, those things are filled with 0 because if I have an empty string and comparing with a string with A, then 0. If I have an empty string, in this case, this is an empty string, comparing with AB, right? This is AB, then it's basically 0. If I have an empty string here, comparing with A, then it's 0. Comparing with AB is also 0. So we're basically starting from here, right? And we're working our way down. So this is basically our top-down approach, a bottom-up approach, because we're going from the bottom, right? We basically, the base case here is we solve these are zeros, and then we look at if those two are the same. If those two are same, then we're just going to be 1 plus the previous row and the previous column, right? Because now if I want to compare A with A, those two match, then I'm going to compare with the remaining characters. In this case, the remaining character is empty and empty, which basically is 0, index 0 and 0, right? So this will give us 0, so 1 plus 0 will pretty much give us 1. So now you can see here we also have A, right? In this case, if I have A comparing with AB, right? This is AB, so at this position, right? In this case, because we're going from row by row, so you can see here, because A does not equal to B, right? In this case, the last character of those two does not equal each other. So what we're going to do is we're going to do those alternative options, right? Is either A comparing with A, or it's going to be AB comparing with the remaining character of the string, which is just basically empty, right? So you can see if I were to go that path, is basically the answer here, right? Because you can see AB comparing with empty string is 0, right? And in this case here, if I want to compare with A to remove B, right? Because you can only go with two options here. You can either go with AA, or you can go with empty, right? Empty string and A and B, right? So those ones is 0 and those ones is 1. We already compute that. So what we're going to do is, you can see here in our code, I know it's kind of overlap on this one, but you can see, oops. So what you can see here is that what I did is, if they don't equal each other, then cache at I at j is equal to the maximum value, either cache at I minus 1 at j, or cache at I minus at j minus 1, right? So it's either the previous row at the same column, or is the previous column at the same row, right? So this will give us the maximum values, either 1 or 2, either 1 or 0. In this case, 1 is bigger, right? And then we keep going down. In this case, we have a B and an A here, right? So in this case, A comparing with AB, in this case, is basically just 1, right? We already did that. And then if I want to go down here, in this case, if I want to solve the longest common substring, for AB. So basically it's going to be this value right here. So because those two are the same, right? B is the same. So 1 plus cash, right? So in this case, DP, I'll just make it shorter. So DP at the previous row, I minus 1 and J minus 1, right? This will give us, just like this one right here, we're getting the previous elements, the previous row, previous column's value, right? So this was the pre-computed value for the remaining characters, right? We just have to retrieve that. Plus, because the current characters are the same, so we're gonna plus 1, right? And at the end, notice that we're returning the last element in the 2D array. And this will give us the time complexity of big O of T1 times T2, and the space complexity is also T1 times T2 as well, right? So basically, this is how we solve this problem, both using bottom-up approach and the top-down approach. So there you have it, and thank you for watching.